I'm going to be presenting on self-knowledge, genetic endowments, and educational achievement. This was joint work with Kevin and Nick over here. Um, it's probably important to say this is pretty early stage research, and so that means any feedback that I get really sent to different directions that we could take this in. But I'm just going to jump right in. All right. So first, I want to motivate why care about beliefs about own ability, which is what this is going to be about. So human capital accumulation depends on your beliefs with a net returns to investment, and that can be moderated by your beliefs about your own ability. If you think you're high ability, you'll invest more. You don't think you're high ability, maybe you'll invest less. The challenge that arises here is that people's beliefs about their own ability might not be well calibrated, so they could be making all sorts of errors. There's some related evidence to this, some research that there's quite a bit of dispersion in beliefs with the returns to mid-capital investment and returns to going into particular majors. There's also some work done in an adolescent sample about dispersion of beliefs and accuracy of that own ability in a cognitively loaded task. And so I think that this can be motivated as important in a couple of different ways. There are both equity and efficiency reasons, I think, to care about these sorts of ability, these sort of self-assessment mistakes. So households with less resources might have access to less accurate information. And so that could reduce the quality of decisions differentially by SES and contribute to inequality. In addition, there could be informational frictions associated with figuring out your own ability, and this could lead to inefficiencies. So high ability individuals might not know their high ability, and therefore they might not invest as much as they should. We could be deprived of, like, the next Steve Jobs or something as a result. And so how do genes come into this conversation? I think there are two general ways in which I think of genes as coming into this conversation. The first is that individuals might have imperfect information, not only of their cognitive ability or other things, but of their genetic endowments. And I think that that's important for a couple of reasons. One is that I think this is pretty important for understanding by interpreting the genetic correlations that we've seen. People's responsiveness to their own genetic endowments is almost certainly going to be a function of how much they know that they're high or low in some polygenic score or have good endowment for a particular thing. On top of that, it could be policy relevant. So the extent to which people have imperfect information is going to govern how important it is, or how much information actually gets revealed once you give people genetic testing results. Is that even a worthwhile thing to do? That we're kind of a long ways off from that being practical, but I think ultimately it's going to be something that's worth thinking about. This first section of ways in which I think genetic endowments relates to self-knowledge about ability. None of the results I'm going to talk about are going to cover this. I just think it's important to know about. The second set of questions are more about how genetic endowments might actually augment the accuracy of your beliefs about your own intelligence or your own ability. There's some evidence that the educational polygenic score is associated with accuracy of beliefs on stock market performance and macroeconomic risks. And you could imagine that one channel through which genetic endowments might affect human capital is by actually influencing your knowledge about your own ability. You might be more knowledgeable about your own ability if it's the case you have a higher EA score. And so this second component is what I'm going to show some preliminary evidence to try and get a sense of whether or not this is even a reasonable hypothesis. Okay, so that brings me to this presentation. What am I going to do? I'm going to explore the interplay between ability, self-knowledge, and the educational attainment polygenic score in the ad health. I'm going to construct a measure of ability self-knowledge in the ad health, leveraging some questions they ask about subjective intelligence, how smart are you relative to others. And I'm going to estimate associations of self-knowledge with educational outcomes to see whether or not these measures actually matter. And then finally, I'm going to see whether or not your EA score is actually related to the extent to which you have self-knowledge about your own ability. And so there, I'm going to have some preliminary findings. Ability accuracy, and there's some evidence of overconfidence as well, is going to predict educational performance on a couple of different dimensions. The EA score is going to predict what I'm calling ability humility, the extent to which you believe that you're more smart than you are is going to be reduced and your accuracy is going to go up with people when you have a higher EA score. And then the association between EA score and self-knowledge is going to be is going to be robust to what I'm calling context controls, just controls for education or school quality, parental characteristics, etc. Ooh, 5 minutes, all right. So people are familiar, I think, at this point with the ad health data in general. So I'm going to try and zoom through this. I restrict it to whites in the sample. The key variables I'm going to use are the EA polygenic score. I flip the sign so that it's positively associated with educational attainment. The picture vocab test of verbal ability, that's what I'm going to be using as a measure of ability. It's measured in wave 1 of the ad health. The context controls to keep in mind would be a school ID fixed effect. The grade you are in school, parental occupation, and parental education. These are things I'm going to control points and regressions. And then I think the newest thing relative to some of the other stuff that's been discussed is this measure of subjective ability, where they ask a question actually in waves 1 through 4 of ad health, where they ask, compared with other people of your age, how intelligent are you? And so this is the response on a scale from 1 to 6. It goes from moderately below average to extremely above average. I guess there's no extremely below average. But, and so just so people understand the distribution of this thing. So here I just have a distribution from 1 to 6 on this measure. People generally think that they're quite smart. So 90% of people think that they're average or above, which is kind of, I guess, what you might expect. Okay, so I'm going to use this measure to try.
So how old are these people? Just the age?
So there's an addition from their ages, their grades 7 to 12.
Oh, okay.
One of the ad health.
So basically secondary school students.
Yes, exactly. Yes. I think the majority being in middle school on wave 1, and it shifts to high school on wave 2, but I'm using wave 1. Okay, so I'm going to use this this self-intelligence measure, this self-knowledge measure to try and create a measure of self-knowledge by actually relating it to where you fall in the distribution of ability. And so I'm going to create 2 measures. There's what I'm going to call ability overconfidence, which is here I'm going to interpret the actual answers from 1 to 6 as predictions about what sextile you're in the ability distribution. There are other ways you could do this, and I'll talk about that in a second. But then I'm going to take the difference between what sextile you're predicted you think you're in and what sextile you're actually in, using as a ground truth the verbal ability score from ad health. And I'm going to only compare you to people within your grade, within your school, just because those are the people that you're likely to actually know somebody, or to sort of create a reference perspective. There are the other one is going to be the stability error measure, where I'm just going to take the absolute value of overconfidence, such as a distance measure, how far away from the truth. And so there are other ways of constructing this measure. I'm not going to get into it because I don't have very much time. Ultimately, construct 4 different versions where you change different comparison groups and so forth. And it doesn't change the patterns I'm going to discuss. Okay, so the first thing that I wanted to do, like you might imagine that these overconfidence and error measures are just like not related to anything. So the first thing I wanted to do was just to see, are these actually related to educational outcomes? And so here is some evidence from regression. On the left-hand side here, I'm just using 2 measures of educational attainment as grade point average and college completion are the 2 that I'm using. And you can see that in general, the your ability error is negatively associated with grade point average and college completion. Your ability overconfidence, there's some evidence that it's positively associated with grade point average, but not so much college completion. And this is conditional on a series of controls for context. This is just to give a sense of like whether or not these measures are picking up anything at all. All right, and the last main thing I want to show is that if you look at the relationship of the EA score and your ability overconfidence, people are generally sort of more humble about their ability. They have less overconfidence, and they're closer to accurate. And this relationship is significant. That's the Pearson correlation coefficient there, and the p-value associated with it. And the other thing I want to say is that if you run a regression of ability overconfidence on EA score conditional on other factors, you see that the relationship doesn't really move around very much. And so as some beginning exploratory analysis, that suggests that maybe there's a relationship there that needs to be explored further. Okay, so I'm basically at time. I'm not gonna, you guys just saw in 10 minutes the stuff. I'm not gonna sum it up too much, but I think the one thing that to maybe think about here is there are there's other prediction accuracy that you can measure in that health. People predict whether or not they're going to go to college. They predict a variety of things, and you could get sort of measure of ground truth of that. It's going to be interesting to do. Yeah, time. Thanks.
All right. Hi, I'm Shubha. I'm a postdoc researcher at the Center for Demography of Health and Aging at UW Medicine. And today I'm going to finally break the streak of education policy. Look at ADHD instead. And this is a paper that I'm working on with Kevin and Abhigyan, who's a graduate student at UW Milwaukee. So what is ADHD? It's attention deficit and hyperactivity disorder. It is defined as an ongoing pattern of inattention and or hyperactivity that might interfere with your functioning or development. Now, whenever we talk about ADHD as a mental health condition, we kind of tend to associate it with children and adolescents. The literature has already looked at the negative impacts of childhood ADHD on human formation and impulsive behaviors. And certainly there is a lot of importance given to diagnosis of ADHD and availability of medication, etc. But we have reasons to believe that some of these cases of childhood ADHD might actually persist into adulthood. And actually, the persistence rate is between 5 and 30%. And some of the past literature was worked on it have shown that adult ADHD is associated negatively with labor market outcomes, with delinquency outcomes, and risky behavior, other comorbid problems. But there is a problem in the sense that not much has been done with ADHD in the elderly population. Right. So there are some papers in epidemiology, but they are mostly done on observational data of 50, 60 people at most. Now, why do we have a dearth of evidence in this field? That's because, elderly cohorts in general might find it troublesome to seek out for help when it comes to mental health because of social stigma. Or there can be other reasons also. And so what that means is that it makes difficult for us to have a good measurement of this mental health condition for the older cohorts. And this is what this paper is going to address. We want to impute a likelihood of ADHD for the elderly cohort in the HRS. And then we are going to talk about what we do with this cohort. So HRS is basically health and retirement study. It's a survey that's carried on every 2 years from 1992. Now, there are two basic sources in the HRS from where we can have some information of ADHD. One is the life history surveys. And as I told you that when these elderly cohorts were growing up, ADHD as a disease diagnosis was not that prevalent. And the awareness was also not there when these people were young. So there is no surprise that only 70 out of 22,000 respondents said yes, that they were diagnosed with ADHD. There is another experimental module in HRS, which asks questions that the DSM, this is Diagnostic and Statistical Manual for Mental Health Disorders, they have come up with criteria to ascertain if you have ADHD or not. And those are based on 9 questions of attention deficit and 9 questions of hyperactivity. So as an adult, if you say yes to 6 of the 9 questions on each of the sections, you have ADHD or else not. So we are going to use this module, and but please remember that only 1,284 respondents have answered to this question. So we still don't have it for everyone. So in this smaller module, we are going to construct a probabilistic proxy for elderly people's ADHD. So what we do is basically, let me go here first. So the first step is we are going to predict 0-1 variable called diagnosis. So in the 2016 sample, based on the DSM criteria, we are going to assign a 0 or 1 ADHD status to all the 1,284 people, right? And then we need to have some questions which will be common in both the 2016 module and also for the entire HRS in order for us to impute it for everyone, right? That's where comes that's where we look into the clinical literature and we find out outcomes which have been proven to be strongly correlated with ADHD. And these are some of the behavioral traits, health outcomes, and the external observation is that of the interviewer's observation. In HRS, they ask the interviewer, do you think that the respondent was inattentive? So these are the questions that we have for almost everyone in the HRS. So now what we do, we first in that smaller module assign you a 0-1 diagnosis status, and then we regress that on these x's, and then we get the coefficients. And then we use those coefficients and the x's in the bigger sample to kind of generate this likelihood of ADHD for everyone in the HRS. So once we have that, this is how the predicted probability score looks like. So what do we do with it? Is it even a useful proxy? So we have collected as much information possible from HRS from several modules, and we want to see if we decrease our proxy on all these, how do the results look like? And as you can see that the direction and the statistical significance on all of these, we can believe from these results that our proxy is very strongly correlated with other measures of ADHD that we have gotten from HRS. So now what do we do with this score? We have this score. So we can use this score in two ways, right? Once we can use this score as like on the left-hand side of the regression in the sense that we can see how life experiences or any other factors would impact this score. And once we can use this score to see how that impacts our life outcomes. So first I'm going to show you how childhood distress, financial distress is associated with ADHD. So in the HRS, we use the retrospective measures and we form a binary variable 0-1, which is high childhood distress. If you have said yes to one of these, you had to ask for help, father was unemployed. And then what we do is that on the x-axis, you have PGI. And on the y-axis, we have formed this 0-1 variable, which is you are quoted as 1 if you belong to the 90th percentile and above on the predicted score that we have come up with. As you can see that there is a pretty flat relationship between PGI of ADHD and low childhood distress. However, the relationship between PGI and high childhood distress is steeper, right? And we cannot comment for sure that what is happening. It's either that, people who are highly predisposed towards ADHD, PGI, for them, maybe this childhood financial distress factor is manifesting ADHD symptoms in childhood, which then maybe is persistent into adulthood. Or maybe it's just that it doesn't affect childhood ADHD at all, but what it does is that it kind of extends symptoms into adulthood. This is a G by E analysis of the same thing. We are not seeing any interaction effect when we use the entire spectrum, but when we use the high probability, the diagram that I showed you, then we see some interaction there. And also we see that it's mostly concentrated within brain, which is, I think, consistent with the literature that ADHD symptoms kind of tend to manifest. The manifestations are very different in male and female. And now I'm going to show you how this score is related to other outcomes in the sense that now I'm using this score as the X variable, not the Y. And I'm going to show you on labor supply and household wealth. And we are restricting the sample to male aged 50 through 65. And we are going to use the demographics, basic demographics, calendar year education, and we are clustering standard error at person level. As you can see that we have run this same regression, like for all the outcome variables, we have run 3 regressions, one with our predicted ADHD probability, one with the survey diagnosis that we came up with using the TSM score, and one is the self-report. And the way to interpret it is, so 11% point is the average difference between someone who is diagnosed with ADHD based on DSM criteria and someone who is not. In other words, we believe that the best way to measure the difference between has ADHD or not is this 11% point. So we are going to interpret it as 11% point increase in likelihood of ADHD. You are like 6.6% point less likely to work. And you can see with the directions and the coefficient, the estimate sizes for the extensive margin, we think that the results are pretty consistent. However, when we look on the intensive margin, that is how much you earn provided you are working, you can see that the estimate on log of earnings for our predicted ADHD score that we had is statistically significant and negative, and it's like 10.6% points lower. However, for the other two, although the coefficients are, the point estimates are consistent, but we think they are imprecise. And that's where we want to also highlight the benefit of the score that we have for everyone now, because that's a larger sample. So we can measure it more precisely. And then we have the same for household.
So quick comments, I guess, for both. For Kadeem, both very interesting comments. Thank you. For Kadeem, just trying to think about the relationship between the evidence you showed and the Dunning-Kruger effect. I don't know if you've heard of that.
Yeah.
That's it seems closely related. This is the finding that people who are higher ability and lots of dimensions also tend to be less overconfident in their ability. And I was also thinking there are a lot of companies now that give PGI information to paying customers. It might be interesting to partner with one of those companies and try an experiment. You know, you could study the effect of giving information on people's behavior.
Do you have a connection to any of these companies?
Let's talk later.
Okay. Okay.
And so the second talk, it's very interesting. I guess one thing that makes me worry about actually is that if we're much more likely to see ADHD in people who were born in these distressed childhood environments, I wonder if the GWAS signal might be picking up partly growing up in one of those kinds of environments. So anyway.
Sure. I have a question for Shubha. Think thought, thanks. When you're training this this measure of ADHD on these, I'd call them sort of symptoms in adulthood, right? So you're sort of assuming that if the person is either diagnosed or undiagnosed with ADHD, that they have done nothing to be able to reduce those symptoms. So first of all, I suppose that you would take out these 70 people that are diagnosed with ADHD, which I guess wouldn't bias your results so much because it's not so many. But then my question is, because I don't know too much about how ADHD overlaps with other traits, but could you expect that maybe people were not diagnosed with ADHD, but they would be diagnosed with something else, or somehow gotten other types of therapy, other types of medicine that would reduce those types of ADHD symptoms? And then as a result, those people would not score high on the ADHD measure that you construct. I think that could also maybe, if those types of measures are going on, explain your G by E that you find, right? If that's sort of stratified by social class. So I was just wondering, did you think of putting any of those safeguards in place?
Sure, no, theoretically, it's definitely possible that through some other channel, you mean like that you were saying that the ADHD symptoms would be kind of depressed, and that's your point.
Well, I mean, if you treat the ADHD symptom, then according to your measure, you don't have ADHD, right?
Yeah, so I like your first point of Kevin. I think we did get rid of the 70, right, when we were training with that.
And
Yeah, we will check that one. But with the other mental health conditions, I think the point that I was making of these elderly cohorts growing up when ADHD diagnosis was not prevalent, I also think it's mental health as an umbrella altogether. I think the general awareness was also not that much that we have right now. With that's my understanding of, like, you know. But then you are right. I am not sure about the other medication routes. I have to see if there are spillover impacts of, I don't know, say depression medication on ADHD or not. But that's a good point. I will look up more. Thank you.
yeah, Mikhail.
Yeah, thank you both. Very nice talks. I want to ask you, Kadeem, about, I was thinking about this overconfidence measure, because we've been hearing a lot about measurement now. like you're essentially interpreting it as being a question of measurement error in your self-assessment versus an accurate test score. And like, of course, you showed us the distribution, so there's obviously some overconfidence going on. But you could also think about it as being a matter of, say, you rate yourself as being in the top, you score lower on the test, so maybe that's measurement error in the test, and your own assessment is correct. But at least I would think that your overconfidence measure is a function of both the measurement error in your self-assessment and measurement error in the test. So yeah, I'm just wondering if you had any thoughts on that.
Yeah, I think that's a really good point. I think the other thing that I failed to mention as I was talking was there's kind of like a ceiling effects interpretation that's like related to this. So it could be the case that you know, everyone generally is like pretty overconfident or thinks they're smart. And people who have high EA scores just happen to be like kind of right. They would even say they're smarter if they could, but they run into top coding at 6. So yeah, so I think that there are all sorts of measurement issues associated with that, and yeah, I'd be curious if there are thoughts about different ways to maybe deal with this. I mean, the fact that the pattern is similar if you use different comparison groups, and so basically you can construct the self-assessment a few different ways makes me, you know, somewhat confident that there's something there, but yeah, it's difficult.
Another question for Kadeem. Yeah, really enjoyed your presentation. Just a question of whether at the extreme, maybe this overconfidence could become something like narcissistic personality disorder, borderline personality disorder. And is there something you could learn from that literature? Do the PGSs for those mental health conditions, you know, put positive weight on some of the SNPs that are in the EA PGS? And then one other thing is just, I wonder if overestimations of one's ability could lead to criminality because people feel like their genius isn't being recognized. And the Ad Health does have these measures of sort of delinquency and things like that. To test that.
Those are great points. Thanks.
Yeah, fair. I have a question for you. I'll try to ask so other people can hear. So at first, simple. Am I right in saying like sort of the straightforward interpretation of your results is that ADHD is like way underdiagnosed at older ages? And then like I think the sort of lifetime consequences of ADHD, if I interpret these in a causal way, seem like extremely negative at old ages. It's not totally clear. Like, do you want to disagree?
Yeah, no, I don't want to interpret it as cause.
I think that's an appropriate caveat.
Yeah.
And it's certainly like a whole lifetime. So like fixing it at 50, it might be, or 60 too late. But it does raise the possibility, at least, of like, gosh, we should be prescribing Ritalin at scale for like 60-year-olds. Like there might be quite effective and useful interventions at these ages. Like, is that a thing worth exploring?
Yeah, it's more explain. Yeah.
Don't put it in the water yet, but maybe run some trials.
Just a quick follow-up with Kadeem. You have the class rank and all the GPA things on the transcript and the self-reports. I'm wondering if you could use both the differences in how they report what they think their grades are versus what their actual grades are, but also the class rank is their rank. Right?
Yeah. Yeah, no, that's I hadn't thought about using the fact that you have differences in the transcripts versus self-reports and grades. Yeah. And that actually, yeah, that's probably, it'd be nice to get more variation in the sort of measurements.
I guess you're also saying something else, right? Which is like you kind of have a peer group that people are comparing to, right? Because it's like if you're using your own class to rank to that, you also have that information from their rank.
And it's something you know at some point in high school, maybe a little bit late in high school. Well, at least my own experience is that the ranks are reported back to the kids. Maybe it's not, not fully, but I'm wondering if that information is more direct than the BTS, or it's like another source of information that the student's receiving, your BTS learning about it, and then the school saying you're ranked 3 out of 100.
Any other comments, questions? If not, thanks to Shubha and Kadeem for getting us started here.